How to install DyMiCo. First, place the tank in a room that's allowed to keep the water between 23 and 28 degrees Celsius. Avoid direct sunlight on the tank. DyMiCo needs to be installed underneath the tank in a dark area. Mind the weight. Be sure that your floor can bear the tank's and DyMiCo's weight. Pumps and tubing. DyMiCo runs with 2 pumps. Once we call process pump, here tons silence 1073.020 or Siche Synchra Silent 2.0 pushes water through the media layer. Here the tons silence 1073.008 or Siche Synchra Silent 0.5 is called DyMiCo return pump. It pushes filtered water from the left to the right compartment. They are easily installed thanks to the 3 parts coupling, which allows easy removal for cleaning. Please check the O-rings are in place. To push water back to the tank, we provide a tons 1073.020 or Siche Synchra Silent 2.0, but you can use any other one. The only constraint is the flow rate. Use a flow regulator or a DC return pump. Install it in the right compartment. The right compartment can also be used as an usual sump for heater or cooling system, UV filter, reactors. We recommend aerating filtered water before it returns into the main tank. For this, please install an air stone in the right compartment. Use a check valve between the air pump and the air stone. The aeration system is not provided with the DyMiCo. Substrates. 2 special substrates are used for bacterial establishment. The coarse substrate is placed in the bottom. The coarse layer needs to be 27 centimeters high. Place the drilled board on the lateral brackets and then the fine substrate up to 13 centimeters height. You get them pre-washed, but rinse them again until water stays clear. For this, use a kitchen sieve or a drilled bucket. Electronic equipment. To feed bacteria, carbon source is added with a dosing pump. Place it in the cabinet in an accessible spot. Connect tubing from the carbon jerrycan to the pump, and from the pump to the nozzle on the process pump. To soften the tubing, dip it a few seconds in hot water. Drill 2 holes in the jerrycan cap, one for the hose and another for air entrance so there is no vacuum effect. CO2 dosing is optional. It is required if the stony coral population is important and minerals concentrations decrease. CO2 injection lowers pH in the DyMiCo down to a set value. Then the substrates are dissolved and release KH, calcium, and magnesium to the tank as a calcium reactor. Solenoid valve is provided, not the CO2 bottle and regulator. Please note the solenoid valve circulation flow direction, use CO2 black tubing, and place a check valve between the DyMiCo and solenoid valve. The CO2 diffuser needs to be placed in the left compartment. Now place the heart and the brain of the system. Aquastar computer and IKS power bar. We use the Aquastar especially to the setup of DyMiCo with unique installed software. You cannot use one which has not been supplied by us. Whereas ports 1, 2, and L1 are programmed for DyMiCo, other ports can be used for other sensors or equipment control. Make sure the Aquastar is properly mounted in a dry spot, shielded from seawater. The pH and redox probes cables need to be long enough to go from the left compartment to the Aquastar left side. Place the IKS power bar between the Aquastar and the DyMiCo system. Be sure that the power cables of the tons pumps and dosing pumps are long enough to reach it. Connect the IKS power bar to the L1 socket of the Aquastar. Each plug is dedicated to one use only from the green light to the end of the bar. Tons return pump, carbon dosing pump, tons process pump, solenoid valve if you use CO2. Connect the 12-volt power supply to the POW socket of the Aquastar. You can now fill the tank and DyMiCo system with seawater. The water needs to cover the substrate layer for a few centimeters. Water levels will stabilize after a few days or weeks running. After the tank and DyMiCo are full, it is time to set up Aquastar. Connect the pH module to the sensor 1 socket of the Aquastar. Connect the pH probe to the module. Calibrate pH probe using pH 4 and pH 7 standards. To do so, enter main menu, calibrate, pH sensor. Press enter. To go further, and the number keys to set the values. Make sure the probe is clean and dry between each step. Use deionized water and paper towel. pH calibration can take a few minutes in each solution. Once the pH probe calibrated, connect redox module to sensor 2 socket of the Aquastar. Connect the metal cap for the first point of the calibration. Navigate to main menu, calibrate, redox sensor, press enter. To correct redox measurement according to pH value, select sensor 1 as input for tank pH value setting. After first calibration point, remove metal cap from the redox black module and connect the redox probe. Clean it and use 230 mV standard solution for second calibration point. After successful calibration, place the probes in the holders in the left compartment. Please note that our probes are especially waterproof. Do not use any other probes. Next step is needed only if you use CO2. To set pH value in the reactor, select Main Menu, Control, and pH Valve DyMiCo. Enter desired pH value during the day and the night. A 7.5 pH for both is recommended for most reef tanks at first time. Don't set a pH value below 7 when you have only a few stony corals in your tank. You can lower it when you test your alkalinity and calcium and notice a decrease. Also set pH lower and upper limits, which activate an alarm. 6 and 8 values are recommended. It is now time to start the DyMiCo system. Go to the main menu, select Run, and press Enter key. After a short time, return pump will run to push water from the left to the right compartment. After probably 30 seconds, it will stop. Then carbon dosing pump will run and process pump. Then if pH is higher than desired value, solenoid valve will open to release CO2 into the DyMiCo system. Don't be upset if the process return and carbon dosing pumps are running for only a short period of time. DyMiCo is processing a fraction of the water volume every hour. The maximum running time for the process pump is 16 minutes per hour. The average is 4 minutes per hour. When the system is stable and fully operational, 50 to 100% of the water is filtered each day. This is sufficient to keep nutrients low. It allows you to get rich, phyto, bacterial, zooplanktons that feed invertebrates and fish.